it gives you the text document if you want to go through and just make sure that you've got everything, what is expected of you, what could be in the exam. Okay, look, you see where you find the page numbers? No. So my assignment that I've opened up is just to remind you, remember to do it and hand it in. Okay, so your document actually gives you everything. Will be out on a Sunday evening. So you can start immediate plan. Yeah, Monday you could be totally planned for science anyway. Okay, guys, so let's just quickly have a look on, I just want to show you this one again. A lot of people at this still wrong, but I have people that did very well and that know what's going on, and it's just the last little step that is a problem. Tangi, and I'm talking to Tangi because he did very well, and I know he worked through all his work of last week. So I'm showing you again, guys, write a balanced equation to show how solid ammonium, here's your clue, solid ammonium chloride dissociates into its components of ions in the water. No. So I have to write this ammonium chloride with an S, otherwise you will lose the mark, with your arrow, and then I want to see the ions. I'll show you the answers just now. And then I'm just quickly going through the questions, and then I'll show you the answers, but I'll also send the answers so you can go through it. The other thing, guys, do you see how much work I'm putting in? I am really sending you everything. If there are documents that you are not opening and you are not looking at that and you're not working through that, guys, your parents are paying and you are not taking advantage. You are not doing your part. I have in this class, really, and this class is where I have 2 or 3 people working. The rest of the people are not working. Those 2 or 3 guys, well done. And like I said, I'm getting paid whether you work or not. You are going to write the exam at the end of the year, and whether you pass or not, I still will get paid. No, so it's not for me. Guys, and I really don't have to do all of this. It's really to help those 1 or 2 people, because that's the pace at which I'm working. I'm working at the pace of my 1, 2, 3 people that are working in the class. The rest of you are falling behind because you cannot keep up. You will fail and you will not be able to carry on with grade 11 and 12. So I'm just saying, if you are not opening some of the documents and you're not using them, you're not marking your work, going back, looking at the information that I've given you, because I've marked your work. So now I sent you back. So you really go through there, not just like looking at the mark and see how much I got. Really go through it and look at it, because you see, otherwise I could have just sent you the answers and mark it yourself, because this is not even counting. No. So why do it? So really, guys, this is a very nice holiday for people that don't want to do it. I don't even keep track of who is in my class and not. I really don't. I'm not one of those teachers. I don't send in my absenteeism because I feel somewhere it's gonna show. I have all the because it's on Edmodo. No, it marks itself. So the mark will come there immediately, whether you like it or not. So I'm not even having to look at that. Okay, guys, I'm just talking to my, unfortunately, it's a big part of my class that's really not working. In the other class, it's not the case. Okay, let's quickly look at the questions, and I'm giving you just my tips. Does ammonium chloride conduct electricity in its solid form? There's your clue. Obviously not, because there's no free ions. JP, you're talking about electrons. It's not electrons. It's all about ions. So there are no free ions. No. Sodium chloride in its liquid form conduct electricity? Obviously, yes. It's a ionic substance. It's not a solid. If it's solid, it cannot conduct electricity at all, because there's nothing loose. But if it's in a liquid, it's loose. No. Okay, guys, so this question, if you can again read through it, but you can see there we're testing for something. But the minute I see this, the precipitate count disappeared. If it disappeared, it can only be a carbonate. Yeah, because carbonates will disappear if I add nitric acid to it. No. So nitric acid is the clue there. So it can only be this one. Then write a balanced equation for this reaction. And then I have Hope. I didn't even try this. Hope, man, I want you to try. I really want you to try. You are working hard enough for you to be able to try. Hope. You must have more confidence. You can afford it because you know a lot. Really, I promise you, you know a lot. So all that you have to do, guys, even if you get wrong. So say, for instance, you get wrong here. I don't know if the people that have seen that, I think Tangi, I can't remember. Tangi, maybe you wrong. I still mark it because I'm testing a lot of other things. So I want to see, can you write a balanced equation? Figure out all the formulas because that's what you're getting marks for. Can you figure out all the states, solids, aqueous, liquids, whatever? So yes, there's your clue. You have to add barium nitrate to whatever you've chosen here. So if you've chosen this one, it's obviously correct. You will get all your marks because you will know what's going on. You will add the two. You will write the formulas for each one. You will write AQ. And guys, have a look at it again. We asked the question last time, and that was because he wasn't sure. So it's a real question for everybody. But you only realize it after the 10th time that you've done it. So some people are still on number 5 and number 6. They haven't practiced it yet. Look here. Solutions. They are just talking about solutions. The minute the solutions, it is AQ. There's nothing else. Can you see it? So this means they have solutions of these things. All clear. You can't see it. This one. Why are they asking you? That one is a solution. This one is a clear solution. So then we add in the barium nitrate, which is in a solution, guys. Its left arrow will be AQ. Yeah. So then I have my arrow, and now something is forming because the barium nitrate and calcium carbonate will form a solid. Which solid will it be? Barium carbonate, because we know carbonates. Adding the barium. Barium is an exception actually for my sulfates, but also for carbonates. Carbonates in general don't dissolve, but this one does. No, one did for some reason. Okay, guys. So you will write AQs for everything because it's saying so, and then you will have the end where you will see which one is insoluble will be an S, and the rest will still be AQ. The next question was easy. You must just pick your solubility rules, and in this one, a solution of silver nitrate is added to potassium bromide is your clue. So your clue is bromide. The minute I have bromide, that's what I'm looking for. So what is the precipitate that will form? It must be silver bromide. And what is the color? I must say that. I have got only 3 colors. I have a chloride that will be white. I have a bromide that will be cream, and an iodine that will be yellow. And that's it. And then this reaction is also easy. You just swap the partners, the swing party. You write it all out, see that it all is neutral formulas, and then one of them is probably going to form a solid. But if not, then everything is AQ. In this case, it was obviously the silver chloride that's forming the solid. Okay, guys, I'm sending you the memo as well so that you can check. But just so I'm reminding you, actually, that's why I did this, just to show you. So for this week, we're doing just 3 more reactions, 2 more ion exchange reactions, and then a third one tomorrow. So let me just summarize it for you in this way. My PowerPoint. There you are. Okay, so it's ion exchange still. That is together with last week's. The ion exchange is what we did last week. So we have 3 kinds of ion exchange reactions and then redox reactions. We won't have time for it today, so we'll do it tomorrow. Grade 10s, you'll see in the work, if you look at the questions and what I'm asking of you, we're going a little bit slower this week. It's for everybody to catch up. We're doing new reactions. For a lot of people, this makes absolutely no sense, this week's work, because they haven't been up to date in last week's works. That's unfortunate, the problem. But then when we finish this week, we finish with the reactions in aqueous solutions. Then we go over and we do, it's again, a lot of concentration, a lot of hard work, and like practicing more to speak. Where we'll do calculations with all of this reaction. So it's important that we know our reactions also for the next part. So that's why we're going a little bit slower. You'll see the work that you have to do is also very little. If you don't understand it yet, remember the work that I'm giving you is the minimum. So there's nothing keeping you from all those think tanks in the chapter. This one that we only have to do, or we only have to do 7, 8, and 9. But the rest of the think tanks, you are more than welcome to do, and I will gladly send you all the answers as well. So no worries. Okay, so there's my joke for the day with all the talking very seriously. If you're not part of the solution, you must be part of the precipitate. This is what we've done last week. Last week, we talked about precipitation reactions. So it's a special kind of ion exchange. So guys, I'm showing you this picture, and maybe it doesn't make sense yet, but if I show you this one, what color will I use? A nice purple. If I show you this one. So precipitation reactions is a kind of ion exchange. Is an acid base, which is another kind of ion exchange, and then there's a gas forming, which is another kind of ion exchange. Here they say it's either a non-redox, so it's either redox or non-redox. So that's the kinds of reactions that we have. So a redox reaction is all on its own. The rest we can basically say is ion exchange. Now, with exceptions, we have done now synthesis, decomposition. So remind yourself of those ones as well, a little bit on the background. Okay, guys, so you see this one we'll do only tomorrow, but these two, since we've done this one, this is what we're doing today. The acid base and the gas forming. This is what we actually want to do. Let's quickly run through that one. And I'm going to clear all drawings. Okay. And ion exchange reactions. I'm reminding you what it is. It's a reaction. Remember, we have 3 of those, where the positive ions exchange their respective negative ions as a result of a driving force. And now this is very important to me today. Maybe this is still fuzzy in your mind, this driving force thing. So we have basically 3 driving forces. That's why we have 3 different reactions now. The minute there is a solid forming, that's the one driving force. So it's driving this reaction to take place. So I have, for instance, this one, and you know this one already. Can you see both of them are aqueous solutions? And then there's something forming, and they didn't write aqueous or anything in there because it could be or it couldn't be. So sometimes it could all be just iron staying in the solution. You've also seen that kind of reaction there, where there's really nothing happening. Really, there's no reaction, so there's no driving force. But then we say it could be a solid, and if it's a gas, then obviously it's a gas forming. So if it's a solid forming, AD or CB as a solid, one of them, then we call it a precipitation reaction. If it's a gas forming, then we talk about it as a gas forming reaction. So it seems very simple, guys, but there is a few exceptions. We also have some gas forming that's not really what we call a gas forming ion exchange reaction. But we're not going to talk about all those exceptions. So So we'll just do a little bit of guessing, and I want you to see it. I want you to realize that it must be ion exchange for it to be a gas forming. So you must actually go and exchange the ions, and then you'll see something familiar. Then you'll see, okay, there's a gas forming. So let me give you an example. You already know what is ion exchange. So this gas forming reaction now looks something like this. We say it's similar to precipitation, except that instead of precipitate forming, we have a gas forming. Okay, but here it's difficult to see. But this is my tip actually for you. I want you to see it. The minute I have a carbonate and an acid, we've actually done this last year. We've said we've done a few reactions with acids, and we said one of them was a carbonate. If I take a carbonate and I add it to an acid, there's a carbon dioxide forming, and a salt and water. So that's a general reaction that I need you to know. But let me show it to you what actually happened. And then maybe it becomes easier if you just remember one thing. So if I exchange my ions nicely, you realize that it's the carbonate and the hydrogen that goes together. And there I've written it, hydrogen, carbonate. It's actually carbonic acid. You know, the acid that is in your Coca-Cola, the fizzy drinks. But you know how unstable it is. If you pick up the bottle and you open it, the minute you open it, it dissolves and it becomes actually water and carbon dioxide. So that's actually what happens. So we say, if you just remember, you are right if you have written it like this. Look, here's the one, sodium chloride, sodium and chlorine, and here's this one. But the minute you write this one, you must see it for what it is. This carbonic acid. Remember, if something has this H in front of it, it's an acid very often. Okay, most of the time. But we say it's unstable, so it will immediately split into that. Can you see the ion exchange now with this reaction? But this purple reaction is not what we're writing. We don't write it like that. No. So you don't have to remember any of this. You can remember what we did last year. So this is what we've done last year. And we said carbonate plus any acid. Remember, I can change this acid. And we're using still our normal old acids in the lab. Hydrochloric acid, sulfuric acid, and nitric acid. So if you don't know the formulas of those guys, you are really have a problem, because you will not realize it as an acid. Going with this one. But the minute you do the ion exchange, you'll see, because ion exchange, I have this hydrogen going together with this one. And then I can only presume that this must be water and carbon dioxide. Can you see it? It's not that difficult. This one shows you the ion exchange. That's why I added this one. It's not important that you know this purple one name. So the only ones that we are going to write is actually this one. We are going to write this one. Okay, guys, and there is my tip. I'm going to show you an example where there's another gas forming. So we want to guess if a gas is forming, that it's a gas forming reaction. But you'll see sometimes there's a gas forming, for instance, and you remember it very clearly from last year. If I add an acid to a metal, I have a salt forming and hydrogen gas. Now that popping sound, that's our classic thing to do in the lab. We take a piece of metal like magnesium and we add it to an acid, and then there's a gas forming hydrogen. It's not a gas forming reaction. Why not? Because it's not an ion exchange. We talk an ion exchange there. We have a gas forming, or then the precipitate, and then you'll see this other one, this acid-base reactions. So let me show you that one. Okay, guys, you all happy with this one? Acid-base reactions is also slightly different. We could say theoretically that it's between an acid and a base. But the previous example was also an acid and a base. I would say it's not a very strong base. So any base with an OH in it, that's a strong base. I'll repeat what I said just now. So we say in general, the formed products are water and salt. Sorry, this is F. Water and salt in ionic, which is an ionic compound. Now we're talking ion salt time. So the product is water and a salt. Usually the salt obviously dissolves in the water. That's why we can't see it. Okay, so there's your example. And here I'm really using a strong base. A strong base, we say they have OH in it. Okay, so sodium hydroxide plus your hydrochloric acid. That will give you, can you see the ion exchange? We're still exchanging ions. I'm exchanging it, then it's sodium chloride for aqueous. Look at water forming. So I'm saying a superficial way to remember this, an acid-base reaction, if I have ion exchange and the only thing that I have that forms is water, that it seems like a driving force, but it's not really a driving force because this just dissolves the whole thing again. And this whole thing was aqueous, so it was water in the beginning. So it doesn't really look like there's a driving force. Driving force means we have things that have changed. The gas we can see, the gas is forming and it's leaving the beaker. It's even going into the air. The solid will form and will just go to the bottom of the beaker. This one we will not see it. So it's not really the right way to say this. Water is the driving force. Now, let me show you what is the driving force. We said this is a special case of ion exchange, a sodium and the sodium hydroxide exchange with a hydrogen in the hydrogen chloride. Now, the hydrogen and the hydrogen chloride and the sodium and in the sodium hydroxide. So we form this water thing, but there's more to it. Driving force is actually this transfer of protons or hydrogen ions. Okay, guys, I want you to think. Why are we calling a hydrogen ion a proton? So hydrogen, if I have the atom, consists only of one proton and one electron. But can you see this one has lost an electron? So there's only a proton left. So can you see why we call a hydrogen ion a proton? Okay, so we are going to talk about protons. And the only reason why is because we have another way of defining an acid and a base. So we say, if I look at this reaction, then I say acids are proton donors. Now, so if you look at my donor here, the acid, there's the acid. They have the proton. Remember, we call it now a proton. Acids are proton donors. So this one is going to give. They're going to give. Bases are proton acceptors. So there's the base. Can you see it? It will actually accept the base. The proton or the hydrogen ion for that matter. Okay, guys, do you see how we form the water? Can you see what is the driving force? Why we say the driving force is actually the transfer of protons, or sometimes they talk about this this competition for hydrogen ions. So this is the driving force. So where's the protons going to go? The proton is immediately going to the OH because it's strongly accepting it. Okay, we have another way that we can summarize that. Say strong acids ionize. Guys, in here we've been talking about dissociation. Also in our little class test, we said when I break it up in water, it dissociates. But we said not acid and also not bases. I didn't even mention that. Look, guys, strong acids ionize. That means they're really forming an ion. And in our case, we talk about hydronium ions, H3O+. But you can say ions, this one, still an ion, hydrogen ion. So it forms ions in the sense that it's not only breaking up. And bases ionize again completely. And what do they form? They form, and if it's a strong base, they form OH ions. Okay, but that's still so easy to see now. You can see that this one is forming an ion. It looks like dissociation, but it's actually ionization. And this one is forming hydrogen ions. Okay, and then for that reason, we say, if I have a solution with a strong acid, we will say there will be many of these ions, and a strong base will have many of these ions. Okay, guys, that's it. I want to end here for today. I want you to go back and to look at this really and try some of the questions. Most of the questions just want you to identify the type of reaction. But you'll see the ones that you obviously can't identify would then be redox reactions that we're talking about tomorrow, where we have a transfer of electrons. Okay, guys, so I'm sending you also this PowerPoint, and you can finish it if you want to, but it's not necessary. I always say, rather wait for us, man, instead of going too fast, and rather try and see that whatever we've done, you understand that. So also go through the memo of the test. Check your test. I can only mark those that have sent it to me. So yeah, what I also want to do is your homework that you're sending in on Friday. Everybody must send it, and please, guys, please send it with a photograph. So do it by hand, because this is only writing of reactions, so that I can see it also clearly, because there was also a problem. I think, Enrico, the last photo that you sent me on Edmodo, I could actually see that very well. You know, that I told you that you should message me personally. It also doesn't matter if it's there for everybody to see. I'm just saying that you could do that. So I think the way that you sent the photo was good. So thank you for that. Okay, and Jack, I can see everything clearly now, and I've marked it, and I've sent it back to you, Jack. I think I've sent it on the assignment itself. So I'll go back to the assignment, and then it's there. So maybe I just quickly show you what it looked like. Where's my Edmodo? It's probably this one. No, it's not that one. I lost it. There we go. It doesn't matter, but I'll show you what my, if I look at my agenda, I find it here easier. Then I find this one here, my classwork, I go on there, and I can see everybody's. If I click on my all students, and I can see this. Can you see I've requested a resubmission? Then if you go on there, you can see it as well. So I can actually see Luke's work here. If I click on it, you will go back, you will see your own work, and you will see my reply back here, and so on. Okay, guys, so just work a little bit, play a little bit around there with Edmodo, man. That's what we have to do. We don't want to do it the old-fashioned way. We want to work with what we get. Okay, guys, there's still lots of time tomorrow for questions. And next lesson, like we say, we're going a little bit slower. So on our Thursday lesson, we'll probably finish early. I'll have questions for you, but if you don't have, so I'm glad to answer some of the questions. What you could also do is you can send me questions ahead of time and say, Miss, get ready for this question and this one and this one. Have it open, then it's always also much easier. And then I can prepare the answers for you and we can talk about it. Okay, guys, have a good day. Please work hard, do your best, and then I'll see you tomorrow.
Bye, Miss.
Bye.